Welcome to Made Up of Wires. We're going to be decompiling some more weapons today. Hopefully with more success than we had yesterday. We did... I was able to go back through that function in Weapon 01 and get a successful match, and we can take a look at what that was. Obviously we didn't do it on the stream though. Sometimes there is failure. Sometimes you need to ask for help. And sometimes you just need to power through. Yesterday was a power through kind of day related to decompiling. So what are we doing? We are decompiling Castlevania Symphony of the Night. We're going to be decompiling some weapon functions. I'm going to try to find my window with information about the project. There is a group of people who are working on getting a decompile of Castlevania Symphony of the Night, which is taking the original binaries from the PlayStation version of the game, the PSP version of the game, and others, using various tools that have been made by different decompile communities, as well as tools that are being created specifically for Symphony of the Night. And we are trying to rewrite the C source code that would enable us to modify the game, study the game, port the game potentially, and be able to recompile back to the original binary versions of the game. I'm failing to load the project page. I hope that doesn't mean I have other issues with my internet connection. It looks like I might have to fix Safari here. I typically keep too many tabs open, which current versions of macOS don't seem to like. While I'm doing this, let's find a process to restart. The way that we have been decompiling and choosing functions is to go look at the remaining weapon functions. There's currently 14. One is currently in the process of PR. There are at least 5 or 6, if not more, that are basically completed but haven't been submitted for PR. They're not mine. Otherwise, I would submit them. They're also not something I necessarily want to work on because they're very close to being done, and the person working on them is an active contributor. Let's see if starting Safari networking helps. There we go. So on the project page, you can get a link to the GitHub repo, which has all of the code that has been submitted so far. The project page includes progress for several of the different binary objects that are currently being worked on. The Dracula.bin is the main program for the game. Richter.bin is the program for Richter when you play as him during stage 0. I'm not sure how it translates to other versions of the game where you're able to play through the game as Richter. The weapon 0.bin is the implementation of about half of the weapons, and there's a second weapon overlay as well, and then several of the stages, many of which have been completed. For nearly all the stages, there's reverse versions as well. And so while there is a castle center stage, there's also a reverse castle center, which hasn't been started. The one exception there is the reverse warp room. So we're going to go look for a weapon function. I was having trouble finding one that I wanted to work on. I was looking at some of these that are nearly complete, and it may be that this weapon 55 function pointer 10 is where we should start. That seemed like maybe the furthest from being complete. So let's pull that up and see if we can decompile that. I'm going to be switching around. When I restarted Safari networking, I lost my chat and other things. Thank you, Lily. Is there a way... sorry, my my tabs are reloading. Is there any way you could possibly tailor a tutorial on reverse engineering code better? Can you provide some more details on what you mean by better? Are you more quickly, more accurately? So I'm going to look for the remaining non-matching weapons again. Like I said, I think I'm going to target this weapon 55 instead of... Usually I'll sort by size. Most of these have been started, however. And we'll pull up weapon 55. So this is the Holy Sword. And we're looking at this function that's going to slot in immediately after entity weapon attack. Looks like everything else in this for this weapon has been decompiled. So I'm going to copy that and we'll start a new scratch. So in doing these weapons, most of them are relatively simple. We're going to have to start moving into some of the stage functions because weapon is wrapping up. And those become kind of more arbitrary. I'm going to close a bunch of this down. If you are new to decompiling or don't necessarily understand what decompiling is, we're able to look at some of the binary objects that are shipped on a disk with PlayStation disks and some of the older systems. This is relatively easy. The disks are encoded as standard CD-ROMs, and so most files we can pull without any tricks. Once we figure out, for the PlayStation especially, there's a very defined entry point file that's always going to be executed by the PlayStation. That has certain things in it that are related to the PlayStation SDK, as well as a main function which is going to call into a particular offset overlay, which is our main program. That main program in turn will load its own overlays, and that's primarily what we're working on here, is overlays that are loaded at particular addresses. And once we know that an overlay is loaded at a particular address, we can figure out which parts are data, which parts are code. And so then we're taking the code, which is machine code that would be executed by a processor directly, using a tool to convert that into assembly language, and then taking that assembly language code and trying to rewrite C code that will match that. For the PlayStation, it was originally written in C, and so we can we know effectively what the tooling was to build that code, and if we can write C, we can use the tools that were originally used to build those objects to try to rebuild them ourselves. I'm going to pause this. Alright, so what I've done is taken some of that assembly for the 004 function in weapon 55, and I'm using decomp.me. There's different ways you could do this. For the SOTN Decomp project, we're using decomp.me, which has been a very nice experience. I've enjoyed using it quite a bit, and it's very friendly, especially if you're just getting into decompilation. There's a few things on the project that I like to do, and usually I start by just getting all the warnings and errors figured out. So I'm going to turn off built-ins to use the PS1 SDK versions of signatures. The signature that my context has, which is like a header file, is different than the one the decompiler generated. So what decomp.me will do, when I put in the assembly that I want to target, it'll run a decompiler that'll produce a machine-generated version of this assembly. And this won't work exactly. The way that the PlayStation version of the game was compiled was using GCC with standard optimizations. So we can't necessarily trust the order of statements as the decompiler produces them. And there's some other things that we're going to have to do to clean that up. So the decompiler gives us a good first pass, but then we need to go through and clean that up. So one of those things was changing the signature. This function does not return any value, but for reasons that I don't know whether or not they've been determined yet, the function signature that is used in other parts of the code expects an integer, a 32-bit integer, being returned. And this version of GCC allows that without warnings. So we'll do that. We have this B8 variable at the top. The decompiler couldn't figure out what that is. We're going to look down here and see how it's being used. I'm guessing this is a weapon animation. So we're going to call that a weapon animation. And I can infer that based on familiarity with this particular area of this code. So what I like to do is, once I've figured out some of the things that the decompiler didn't necessarily know, I put that in the context and then I rerun the decompiler, which should allow the decompiler to infer some of the types that it couldn't figure out earlier, and give me a slightly cleaner starting point. In this case, temp v1, it looks like this is trying to pull a specific field. So this will have to change a little bit, but it's a starting place. And then the next thing I do when I start, we have these symbols for the player entity. These are part of a macro, and we map these symbols in a text file so that when files are being extracted, we can have addresses that are the addresses are replaced with names that we can understand and know to replace. The big thing here is that these are going to be using struct access. gPlayer, or player, is a element in an array, and it's the first element in the array. So there'll be things like this line on line 25. In C, you can access an array as a pointer, which will give you the first element, or you can use array access to get to that first element, which is what the player macro does. So I made a bunch of mess by doing that, and I'll go clean that up. I haven't showed this before on the stream, but it can be interesting to see how these things come to be as well. I'm going to flip over to the terminal and show that as well. So there is this file is symbols.us.txt, and it has names for all of these addresses that the decompiler, or sorry, that the assembly extraction process will use in place of these numeric address values that are compiled into the final binary. So we know that G entities, for example, is at this particular address, and we also know that the first entry in G entities represents the player entity. And so along the way, people have come through and basically annotated all the offsets and addresses for each of the fields of that player struct, so that when we come through and decompile, we can replace those direct address names with struct access to the same thing, which is very helpful. All right, so we have a few more down line 19. So it's upset about this array access still. This may not be correct, but we'll start here and fix it as necessary. And so this was originally loading a unsigned 8-bit integer, and I'm going to confirm, but I'm fairly certain that this is the first field of... no, it won't be. Let's look at what that is. I was betting that that was going to be a weapon animation, but it looks like it might not be. So I'm going to look for that address and see what the data looks like, and see if we can tell what that is. Yeah, so the most obvious thing right now is that it's a byte array. It may be something more, but we'll change it to a byte array and go back to the way that was originally written. It's relatively common for that to be a weapon animation at the beginning, which is why I assumed that it was. Okay, so we've gotten to the point where we're compiling. We're at 75% match. I would say that this is basically all of the decompiler's work. Everything that we've done up until this point has just been cleanup. So now we have to go do the last 25%. So it's pretty nice being able to start with so much completed already. What I typically like to do is go through, clean up those player underscore variables, clean up the G player variables, and then clean up these G APIs function calls as well. This is very similar, where these are elements that are in a struct that we've named G API or game API. And these are fields that store function pointers, which means they can be changed at runtime. I don't believe they are, but they could be. All right. And then there's a few go-tos that looks like we could get rid of those as well. It's hard to type when everything's going so slow. So this go-to block 15, it was a effectively sending us down here to line 86. We can make the opposite side of this condition an else statement, and that will give us the same effect. And likewise, this go-to block 17 here, we can also make that an else statement so that this condition does not fall there. And our block 17 is to destroy the entity and exit. And we're going to see above that we have this very deeply nested conditional, and we can invert that condition and reduce some of the nesting, maybe in a few of these places. And currently that doesn't get us any closer really to decompiled. but this should. When we want to invert predicate logic, we have to invert all of the comparisons and then change the ands to ors. And that will give us the opposite. So a greater than equals becomes a less than becomes a greater than equals, and a not becomes a equals. And now we can bring this block up here and reduce some of our nesting. And that did improve the coverage by about 4%. And when looking at other versions of the game, like the PSP game, it's more obvious that this is the way the code is structured. The PSP version, you can see pretty clearly what all the steps are and what order they're coming in. It's not always clear, at least to me right now, looking at the PSP assembly, what some of those things are. I like the disassembly from the PlayStation 1 a little better. I think there's some other places we can do this as well. So here we're looking at the primitive index, and if the primitive index that comes from allocate primitives is -1, that means the allocation has failed, and we're going to destroy the object and return right away. So we don't have to put that logic in the end. This is a way that I prefer to program as well, which is to get rid of the exceptional cases and allow the main logic, do some checks. If something's wrong, in this case the allocation failed, and you need to return, do that right away. Don't intermingle it with the rest of the logic and have a condition that you have to go searching way down, several pages down to find. So I'm kind of glad that a lot of this is written in that style. The primitive index is really only going to be used up here. There's some cases where it is a separate variable, but in this case we can get rid of the separate variable and just use the field directly. And this var_s2, we'll go a little further before we start renaming things, but we're going to call that prim. Actually, I'll do that right now. So the next step kind of in the process that I like to follow is to start renaming variables that with known common names, because that'll make it easier to read, and it also will point out common patterns between different areas of the code. And so this this var_s2 down here, this is also going to be that same primitive pointer. And we'll just choose one of these then. So the next thing I see kind of on my way down is this var_v1, which looks like an x offset, and that x offset is changing depending on what whether or not the player is facing left. The PSP version is nice for some of these checks. GCC, especially when it's optimized, this 2.6 version of GCC, checking this field against whether it's not 0 or implicitly checking the value for non-zero is going to produce the same code. The MetroWorks compiler without optimization on for PSP does not do those things. So when this code has to match both PSP and PlayStation, it's nice to know what some of the common idioms were, so that we can kind of prepare this code for that as well. So I'm going to call var v1 x offset. And in this case, I'm going to make an assumption that this isn't setting the negative value, but just negating the original value. Again, that on the PlayStation version that is run through an optimizer, that won't make a difference. It's more a hunch in how the PSP version was written. So far we haven't really even been looking at the assembly. I've kind of been keeping track of, as I'm making changes, is it getting closer or further away from matching? But those aren't always going to align. Down here is a pretty common pattern for a for loop. The decompiler doesn't write for loops for us. It always will write a do while. And that's, again, likely because of the optimization level. If you look at how you might write a for loop, you'd say for I equals 0, while I is less than 40, I plus plus. Here we see that the I in this case is var s3. That's being incremented in the middle of all these other statements. And the first check isn't being done until the very end. And all of that is logically the same. It's just not what we would expect if we were looking at code that a human had written. So first we're going to change var s3 to I. This var s3 underscore 2, it's also going to be used in a for loop, so we'll take care of that one as well. And then we'll come back down and rewrite this as a loop. Or a for loop, I should say. It already is a loop. So one thing that is common in these weapons and any of the entities, when they're setting up the primitives for drawing, they're going to allocate a list of primitives and pass in how many they want. And then typically we're going to go through and we're going to iterate over that list, and we're going to iterate over exactly the same number. And this is no different. These primitives have details about how this is going to be drawn, so this holy sword in this case. I haven't gone through and looked at, so entity weapon attack is when you press the attack button, what happens next. And then there's several other functions that get called at various other stages. And some weapons implement them and some don't. I haven't stepped through, though, in a debugger to see at what stage are these weapons called, and they haven't been given a name, so we just call them their address. All right. So I am going to do some cleanup here. We have this temp v0 _2. We should figure out what that is for. Where the value is coming from. Oh, it's this random value here. So let's assign that to x3, and then we'll use that value from x3. When I see the RGBs, so red, green, blue colors being set in primitives and they're in order like this, I typically keep them in that order. If they're in the opposite order and the decompiler writes them as BGR, I'll put them in one line. The decompiler will, assignments happen, I should say, inner to outer. And so the decompiler doesn't know whether they're on one line or whether they're set separately. There are some hints, and the PSP version actually requires you to do one or the other. The GCC version, in this case the PlayStation 1 version, does not. Typically priority is set before draw mode. So now we'll go through and look at some of the assembly and see if that's the case. So we'll find our line here, line 52. So we're not matching. I'm going to reorder these lines, and this should fall into place. Yeah, and so most of those are matching now. The reason that this is misordered by the decompiler is because this draw mode assignment is happening here on line 52, but then the priority assignment happens later and is ordered differently. Why exactly GCC decides to split those lines up, I'm not sure. I'm not sure if there is any advantage to not blocking these remote loads from memory. If this next instruction can assign to this register while those other operations are occurring. I'm not sure what the pipelining and other things like that look like in mid-90s MIPS. That's why that might be done today, though. So we have some other things that are out of order down here. This animation set, palette, unknown 5A, typically come in that order. So we'll reorder these, and that should fall into place as well. This is a plus equals 2. The GCC version, again, isn't sensitive to that, but the PSP version will be. Same thing here, same misordered Z priority. I'm down on line 69. There is some, these look out of order as well. I'll try flipping those, and we'll see if that fixes it. No. This is going to be a plus plus. This also likely comes after as the final line. In this case, though, it is being set almost immediately after set weapon properties. Let's try it before and see if that makes a difference. No. So there's some ordering there that seems off. Typically, incrementing the step is one of the last things. In this case, though, it isn't happening in order. GCC will reorder these as it sees fit. I should say the optimization pass will reorder these as it sees fit. It's assigning values to different fields in the struct that don't overlap. And so it is, it gives itself leeway to do whatever it wants there. Here I'm going to get rid of this temporary variable. Yeah, I don't like that this... that this add is missing. And we could look at what these offsets are. 2C, 3A. That might give us a hint as to what's happening. Yes, Mozilla, I am Sulako on Discord. I like to use different names on every service. No, not really, but yeah, I am Sulako in the Discord. So 2C is the step, and 3A is enemy ID. So we are incrementing the step earlier, but it almost seems as if it has to happen after the properties are being set, and maybe this is more likely. Nope. We'll come back. That's a little closer. Not quite correct yet. We can look down here too. Offset 12. Oh, am I not switching back? So I move both the enemy ID and the step increment up from the bottom of this, which does make this closer. The 2C, however, it's almost as if when it finally does get set, it's happening much later, and maybe that is what it is. Maybe the enemy ID is getting set up here, and the step is being incremented. Okay, that's what it was. So it pulls out the step value really high immediately after set weapon properties, but then doesn't actually do the assignment of that increment until one of the last steps. So now I'm going down further. We'll rewrite this do while as a for loop. And we're, again, looping 64 times because that's how many primitives were allocated. And find where... So most of these things fall out, and it's not until line 102 that we run into some problems. So temp S0 is being used down here in this call to our cosine we should be able to pull that directly. Possibly not, though. We'll see in a second. We may need to pull this out. Actually, I'm going to do that. I'm going to rename temp 0, S0 as angle, and then temp S1 as scale. They may be able to go away. However, when fields are being set on the struct that is being, where the data is being pulled from, sometimes GCC will reload those. That's kind of what the optimizer decides to do there. I find somewhat difficult to predict. I'm going to get rid of a bunch of these casts just to make this easier to read for myself. I will take any comments in chat if you can tell me what Sulaco is from. So Sulaco is a name that I go by PSN and Discord, a bunch of other places. So on line 102, the difference that decomp.me is pointing out is we have load high, or half, sorry. Mentally I always think high. Load half, so a 16-bit value versus the one that we're generating, which is load half unsigned. I think I just got rid of one of those casts. So we need to tell the compiler to treat that as a 16-bit signed value. And possibly change our angle and scale. Well, those are signed. When that doesn't happen, we can brute force it by convincing the compiler that this is actually a pointer to assign 16, and then dereferencing that pointer, which should give us the correct instructions. That it's being loaded as unsigned. Okay, that did not work as I was hoping. Let's find out where this temp S5 is coming from. So temp S5, we can rename that X, and S4 we can rename Y. So we're doing a bunch of shifts that aren't showing up in the compiled or in the original version. These shift rights are, though. And we are still missing one. Sometimes those come from the casts, so I'm going to get rid of the casts and see if that cleans any of those things up. And this actually might, the PSP version may provide a better idea of what might be going on there. I'm going to leave it that as it is for now. These did not end up doing anything. I may try putting those in line and see if that changes how they are treated. So angle is the x2 value, and scale is x3. No, that's further away. So I'll leave this for now. Some of the geometric work I have to spend a little time thinking about, and it's it's mostly me staring at the wall. Which doesn't make for an interesting stream. So let's go back and try to fix these other things at the top. And hopefully we'll get a match soon. The decompiler puts in a lot of unnecessary casts, which makes it hard when there are necessary casts. I've never, yeah, okay, so comment is, surprised that I don't use dark mode. Never been a fan. I don't know. I do like a black terminal with white on it, but for some reason in my IDEs I have always used light mode and never got on that bandwagon. Too cool for me. Alright, so this O1C is the rotation Y, and 30 is params. So let's separate those out a bit. Oops, don't get rid of them. I'm trying to see if I can... I'm not worried about the immediate differences. Again, these are symbols that we have mapped so that when the assembly is created, we get nice symbols, but really we want these offsets from G entities. So up until line 17, all of these are matching, and then we start mismatching here, and params gets loaded before we're ready for it. I'm going to pull that out into a separate variable and see if that can, if we can reorder those statements a bit. Okay, so that did change what was being generated. This is still happening, not in the order that I'd prefer. There we go. So I was pulling a reference to So the address of this params element, but really I wanted the value of the element in the array. And that was a mistake from earlier when I thought it was a weapon animation. That helped out quite a bit for this initial part. Well, let's go down to line 33. Oh, that's fine. So now it doesn't like... Again, it's loading an unsigned value when we want a signed value. And it's not taking no. There also then is this line here. It's loading offset 6. Oh, that's the high position of pos y, which looks like it's happening out of order as well. So this is a sort. I might go look to see if there are other examples where this is being pulled out like this. I doubt that these are out of order. It's possible that this is being set here. This is getting into just guesses though at the moment. Yeah, and that's further away. I'm going to revert that. This is relatively typical. Oh, it's possible that these are out of order, and that might fix the signed problem. It doesn't. Yep. We'll keep moving on from there and see what we can find next, and if any of that falls out. So line 40. To the moon. We're going to the moon. So here's an example of this addition of O1C, which leads me to believe that these actually aren't happening before this step. So the decompiler and the compiled assembly actually has all of these instructions up here, but it knows that we'll see. There's some possibility that these may be occurring later. You would have to pull these offsets with it as well. Sometimes this happens when the compiler thinks that in the most likely scenario, this code is going to be generated or going to be executed regardless. We do have returns up here, so that's less likely because there is at least one path that would prevent this code from running, and so it might not infer that it's that important that it can do ahead of time. And it looks like that was the case. Many of the weapons, though, do set up these offsets much later. So it's worth a shot to try. There's something about these, though, that that isn't matching. I'm going to go look for some of the other code that sets up these X and Y offsets. So I'm going to grab some context before and after. And so, for example, this this weapon 52 looks very similar. We'll take a look at that. So these are being set very early. One of the main differences here is that they're pulling out the Y version into a variable. The PSP version would help identify that. It doesn't appear to improve the state of things here, though. So one thing we can tell from the assembly is what order these arguments are coming in. So in the original, we're adding V1. V1 is the value at offset 2, which is our player position X. And then the second argument is V0, which is, in this case, the shifted right value. That may indicate that this is a uh, 32-bit value, if there needs to be a shift. Let's do the same for X and Y. Or maybe X and Y are the 32 bits. Yep, that was it. So in our case, we probably don't think much about at these scales whether 16-bit or 32-bit values are the correct to use. But the original code and the original authors did, and so we have to emulate what they were thinking. So now we'll go down, and this could be the same as well. Down here, angle and scale, may very well be 32-bit values as well. And that looks to be the case. And now these shifts may make more sense that were missing from the original. So the decompiler was the one that chose the size of those integers. But sometimes the decompiler gets it wrong. And so this is not looking right. Let's try, I believe. All right, so I took those out originally because I assumed that they were for scaling. Usually shifts by 8 aren't used for scaling between half words and words. But what we're left with now is all of our instructions are correct. So likely this code would function identically to the original. However, there's register mismatches which indicate that something is amiss, and often it's due to either variables being used when they shouldn't have been used, or instructions in an order other than, or maybe variables that haven't been used, or instructions in an order that wasn't anticipated. So we can look at what some of these might be and what the root cause is. So on 107 is where this starts. 107 is using the S1 register instead of S0. It may be as simple as reordering these. And it may be that something like this is ordered incorrectly, but that seems fine as well. When I see these X values that are out of order, that's usually suspicious. So one thing I do see here, come back. Let's throw this in the permuter and see if it can reorder these for us. We're pretty close. We're almost at a match. I think I can get rid of some of these as well before we go there. This temp1 is the animation duration. No, maybe it's the, looks like the trigger for when to destroy these entities. Um, 267 is an odd number. Usually these are multiples of 5. So it's somewhat curious that it's... the reason is because of the stack being off. And the stack being off actually may be the cause of those other register misallocations. So let's try to figure out what the right value for this is. And it may be none of these. It may be that this was used in line. But it doesn't look like that's the issue. That doesn't change how this compiled, though. I'm going to step away for just a second, and then we'll continue on. To recap where we are, this is weapon 55, Holy Sword. This is one of the support methods for that weapon. We're at 98.98% match. The things that are missing, our stack is too small. We're missing two 32-bit values somewhere. And that may be all that's necessary to finish this off. So give me 1 second and we'll keep going. All right, excuse the absence. So I think what we're going to do is, instead of poking around trying to move lines and other things like that, I'm going to pull the PSP version, and then we can see how close this implementation is to the PSP implementation. There certainly will be differences and things that are incorrect, but that may shed some light on what variables we're missing. Where's my tool? I'm going to copy that assembly. I do have to figure out which one it is, though. So there's only two functions implemented in Weapon 55. There's Entity Weapon Attack and then this function. So it has to be one of those two. So I'm going to look at the... nothing has been decompiled for the PSP version yet for this particular weapon. So I'm going to look for all of those and find the two biggest ones. The bigger of the two is going to be I'm not sure actually. So let's look at the PlayStation version and we'll see which of those two is bigger. Oh, Entity Weapon Attack for this one is completed already. So the PSP versions are always larger than their PlayStation counterparts for this particular game, based on the optimization level that was done. And so we can't tell necessarily, except that these have the same kind of offset naming convention as the PlayStation version, where in the PlayStation version this would be Entity Weapon Attack at this offset, and then these would be the 004 functions. So I'm going to copy that and we'll go over to the PSP version. I don't think I'm going to get a clean decompile, and usually that's fine. So I'll choose PlayStation, and paste in this PSP disassembly. This comes with a line to include the macro, and that needs to be removed. The other thing, and let me see if I have it in this context, there is a slight difference in primitive size between the two versions, and I need to make sure that my context has the right version in it. Otherwise, there'll be a bunch of mismatches that are not things we actually need to fix. I don't have that in there. I can modify that though. Yeah, so there's an extra 32 bits after this next field in the primitive. I'll add that in there. So I'm going to ignore, actually we can look at the decompile, which might give us some hints. So it uses params inline. It doesn't pull it out into separate variable. That may or may not be true. We'll have to see. But I'm going to take everything that has been worked on for the PlayStation version and paste it in, and ignore the symbols because those are going to be either missing or the addresses are going to be different. So there's some work done right away, and it's possibly this, so pulling out the params. So this happens first in the PSP version. And it looks like it's happening inline. Possibly not. Those may be split. Oh, it looks like they're split actually. So params is pulled out first and then used later on. It also appears that the shift is not happening here. But it does look like this is being shifted after the mask. Okay, so there still is stack differences between the two, but this is a match. Now we can take this back over to the PlayStation version and compare them and see, are we still close? Let's actually change things slightly. It could be that these are being done differently between the two versions. And most of the differences that we're seeing here are just stack offsets that are different. One hack that is often used is to just stick a bunch of padding at the top to get the stack to be the right size. Usually that will just cause issues later. And actually I'm not as familiar with the MetroWorks compiler. It actually looks like it may be ignoring that because it's unused. The GCC will accept that. So there's a shift here that's missing, and then we saw that in the PlayStation version as well. A load upper immediate at this particular address. So it appears that this anim value is being... I was going to say that it was... being pulled out into a variable, but it doesn't look to be that way. It actually looks like this is being done inline. And the PSP compiler will, regardless of what I write and whether it's used or not, we'll put those lines in. I'm going to invert these because it looks like the load is in the opposite order. Looks better. Okay, that's slightly worse. Give it another shot with a variable. Really no better. So in our version, I mentioned this in some of the other conditions. So for example, this player facing left, let's go down and look at that. We're loading this player facing left. The way the decompiler wrote this was player facing left does not equal 0. With the non-optimizing compiler, it's going to do a couple things. First, it's going to mask this to 16 bits, and then it's going to do the comparison. If I change it to equal 0, this case it's fine, but up here it looks like it's actually loading a 0 immediate value and doing the comparison that way. And so we're going to change this to just a not, and not actually do a comparison against a numeric value. And that is going to clean up some of this. Not perfectly, but close. We're loading we're missing a load of a byte. At offset C. Let's look at this decompile and make sure that it thinks it's the same field. It doesn't know what field it is. It is possible that this is something slightly different. I may leave this here for now and come back to it. So we did get something that was relatively close to match. Let's pull this over to the PlayStation version and see if that changes anything at all. No, we're still slightly worse off. This often happens when going between the PSP and PlayStation versions. We expect the code to be the same between the two, and often can get a match where the code is identical between the two. But there are some cases where you make progress in the PSP version, and that takes you back a bit from the PlayStation version, and vice versa. So there's this this push and pull. I'm going to try the pad trick here. I don't think it's going to work. It does clean up our stack. It doesn't clean up the registers at the bottom though, which is what ultimately we're trying to do, is fix these final registers down here. And like I said, there's probably two more 32-bit variables that need to be introduced, and in such a way that the compiler knows that it can't optimize those out, or doesn't believe that it can optimize them up. Yeah, really it looks like it's just these two, these last two that are just being assigned different registers. So I'll have to go through later this afternoon and do some tweaking. I might throw this into the permuter and see if it can give me a hint. But my time is running out for today. I'll get that started. As always, if there's anything anybody would like to see, or any area you'd like me to cover, I can try to integrate that and help as possible. This is interesting. Unknown 4C. This was renamed recently. We'll get the permuter going and let it run for a while and see if it can find an obvious register swap change. Otherwise, I'll keep going through the PSP version later tonight and try to figure that out. So we've been decompiling one of the weapon functions in Castlevania Symphony of the Night. I made it most of the way through, just missing some register allocation, and logically it looks like what is there will work. If you'd like to know more about how you can follow the progress of the Symphony of the Night decompilation project, you can go to SOTN.z.dev. There will be progress there for the modules that we're currently decompiling. Also a link to the GitHub repository where you can see any of the code that's been checked in so far. And a link to the Discord server where myself and many others are figuring out the best ways that we can go about decompiling and getting a set of source code that will compile back to the original game that can be used for whatever fun you can think of. That's all for today. Tomorrow we'll be back. I'd like to get a demo of running through the debugger and using that to be able to name different functions. So we might look at the Richter prologue there, and I'll see if some of those functions still exist that don't have names. And if there's anything else that people would like to see, chat, follow. You can check out YouTube for previous videos. And I will be back tomorrow. Thanks for watching.